Electronics is a massive field, but at its heart, it's all about controlling the flow of electronic electrons to process information, transmit data, and manage power. Here is a foundational breakdown of how the field is structured from the basic building blocks to how they are applied. The core components. Every electronic device, from a simple flashlight to a smartphone, is built using a combination of these fundamental components, passive components. These components don't require an external power source to operate and cannot amplify a signal. Resistors limit the flow of electrical current and drop voltage. Think of them like a kink in water hose. Capacitors store electrical energy temporarily in an electric field. They act like tiny, fast charging batteries that smooth out voltage fluctuations. Inductors store energy in a magnetic field when current flows through them. They resist changes in current and are widely used in filters and wireless tech. Active components. These require a power source to operate and can manipulate, amplify, or switch electrical signals. Diode allow current to flow in one direction only. A light emitting diode is a specialized diode that glows when current passes through it. Transistors, the absolute backbone of modern electronics. They act as either an amplifier or a switch. Billions of microscopic transistors are packed into modern computer chips to represent the ones and zeros of digital data. Integrated circuits, a collection of thousands or billions of resistors, capacitors, and transistors shrunk down and packed on to a tiny piece of semiconductor material, usually silicon. The two main branches. Electronics is generally split into two domains based on how signals are handled. Analog electronics deals with continuous, smoothly varying signals. How it works. Voltage or current varies continuously with time to represent information. Examples: audio amplifiers, traditional radio transmitters, and raw sensor data, like a thermometer measuring a gradual rise in temperature. Digital electronics deals with discrete binary signals. How it works. Signals are snapped to two distinct, two distinct states, high or low. Examples: computers, smartphones, microcontrollers, and memory devices. Digital electronics are highly precise and less susceptible to noise than analog systems. Key subfields and applications. Because electronics powers the modern world, it branches out into several specialized disciplines. Embedded systems, designing dedicated computers meant to do one specific job inside a larger device. Examples include the cruise control system in a car, the firmware in a microwave, or an Arduino Raspberry Pi project. Power electronics, the art of converting and controlling high voltage electrical energy efficiently. Examples: cell phone chargers, electric vehicle drivetrains, and solar inverters. Telecommunications, designing circuits to transmit data over distances via radio waves, fiber optics, or cables. Example: 5G networks, Wi-Fi routers, and satellite communications. Instrumentation and control using sensors and electronic circuits to measure and automate industrial processes. Where to begin learning? If you want to dive deeper into electronics, a great roadmap looks like this. Learn Ohm's law, the foundational equation of electronics V equal to IR, which explains the relationship between voltage and voltage, current, and resistance. Get a breadboard. A breadboard allows you to plug in components and build temporary circuits without needing to solder anything. Start with a microcontroller. Snagging a basic development board like an Arduino is the easiest way to bridge the gap between software and physical hardware. Writing code to blink an LED or read a temperature sensor